Hello everyone, welcome to MathSci Easy. Today we are going to discuss about a total resistance question. Now this is an interesting question because I've seen like many students make mistakes on this question. Now what most people do is to get that total resistance between A and B, they usually start from this side thinking, okay, 6 and 10 are in series, so they add them up, and then that is in parallel with that, and then so on and so forth. However, this question is a quite peculiar question for a reason. The reason is, can you see this branch here? This one here. And that one is a completely resistance free path. So when current starts to go down this route, say it can come from either side, they haven't indicated the positive side, but let's say it from the left hand side, and the current will split here, right? And it will, a portion of current will go that way, and some more current will go that way, right? So that's capital I. If this is lowercase I1, I2, and I3, so capital I equals I1 plus I2 plus I3. That's Kirchhoff's law, right? Kirchhoff's first law. Now, this current will go down here, I3, and now here's a junction. And what most people think here is they think, oh, current will split here. Actually, current does not split. The reason why it doesn't split is, look at this highlighted path. This is a completely resistance free path. So there is no reason for the current to go in this branch or any of these branches here. So the bits that I'm highlighting with yellow, there'll be no current. So there is no current through the bottom half of this circuit. We call this a short circuit. Here's a short circuit. So what will happen is current will only exist in the top half. So what you really need to understand is the real circuit becomes a part of this. Let me draw that circuit now. The part of the circuit that is really relevant is just this. So to find the total resistance between A and B, all you need to do is, you don't need to worry about this bottom bay, you just need to find the total resistance of this path. And now we can clearly see that this 4 ohm resistor here and this 12 ohm resistor here, these two are in parallel. So how do we know these two are in parallel? Because we can see they are both connected through the same ends. So what you can do is you can find the total resistance. So 1 over R total is equal to 1 over 4 plus 1 over 12. So 1 over R total is equal to 1/3. So R total is 3 ohms. Now the total resistance of this part is now 3 ohms. Now we can simplify this circuit and draw it again. Here is the simplified version. So I replaced the 12 and 4 with a 3 ohm resistor. Now that 3 ohm resistor is now in series with the 5 ohm, and there you get a 9 ohm resistor in parallel with it. Now the total of these two resistors is very easy to calculate, just 8 ohms. You just add them up. Now you have this 8 ohm resistor in parallel with this one. So 1 over R total is 1 over 9 and 1 over 8. You can put this in the calculator and take the reciprocal. So the value of total resistance is 4.2 ohms. This is the final answer. Now, many people, many students get this question wrong. I have seen this over the years because especially not realizing that there is a short circuit. So whenever there is a short circuit, the current will completely bypass this part and it will go through this one. It's a very interesting question about the total resistance.